The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. It's now good afternoon everywhere in the continental United States, I guess, and in most of Canada, or all of Canada at this point. So good afternoon, everyone, and welcome to Hackett's Cove, Nova Scotia, where Mr. Mike Woods and I are here to provide some information about the opportunities for upgrading the V Series FM transmitters from Nautel to higher HD injection levels. And it's a gorgeous day here on the shores of St. Margaret's Bay, blue sky and not all that cold, although my definition of cold may be different than some of the rest of you. In any case, thank you for joining us. I do want to let you know that there is the opportunity for each of you to ask questions. Those can be typed right into the GoToWebinar user information system there. You've got the GUI there, and you can type those in, and at the end of the presentation, Mike and I will do our best to answer any questions that you may have. We don't intend to take a lot of your time this afternoon, but we wanted to provide some information. The basic information we're going to go through is an introduction to digital HD radio, increase in injection level, alternatives for coverage, how to go about or what the opportunities that we know about today are for the V Series, and then an opportunity for questions. Mike is the head of development with Nautel, been with the company how many years, Mike?
23 this August.
23 years, but who's counting, right? Thanks for joining us here. So the first question people will have here is why is a power increase even required? People have talked about building penetration and more reliable outdoor coverage to the 60 dBu contour and beyond, and better reception in portables. But in reality, the real problem in most cases is a noise problem, isn't it, Mike?
That's correct.
Basically, what happens is these HD sidebands, as the system was originally designed, were the total HD power is 20 dB below the HD or the analog FM carrier. And while that works very well in a very clean, quiet environment, when the noise floor rises, it begins to challenge those carriers. And if it even goes higher, why, those carriers can be gone. You still have a reasonable FM analog signal because of the capture effect, but the HD sidebands can be gone. So therefore, the idea of having equivalent coverage for your HD relative to the analog, well, that suffers a bit.
Right. So
here's an example of what happened, some tests that were done in the Boston area. And these were driving tests, and at minus 20, you can see that the coverage area, working coverage area, which is defined by the green areas, it broke off significantly below, before the reasonable coverage area of the analog signal, which is defined by this line here. And you can see as they increase the coverage to minus 14 and even to minus 10, that coverage pretty dramatically improves. And this is most important in major metropolitan areas because the noise environment is very much higher. Okay? Let's talk about the timeline of how we got here. The V Series with the M50 exciter was developed and introduced in about 2004. And then in 2007, they began testing minus 10 because some of the coverage area, as we just said, wasn't as good as it could be. And there were 9 special temporary authorities issued by the FCC for minus 10 testing. A whole lot of things have happened in the meantime, and at the end here, in this year, just recently, the FCC approved the power increase finally. So now what we're trying to do is to find what the best alternatives for our customers to get to that higher HD level. The key points of the most recent report and order is that there's a blanket 6 dB increase for all stations except Super B and C stations. Beyond 6 dB, up to 10 dB, subject to a formula developed by NPR. There's established procedures for remediating harmful interference cases above minus 20. the FCC may revisit the issue if widespread interference results, and that asymmetrical sidebands are not specifically addressed. Presumably, they would be allowed, assuming that they're compliant with established interference criteria in the report and order. So some people already know that they can go to -14.
Right.
Some people need to work with their consultant to figure out what level they're going to be allowed to get to. And this is really an issue that you can't figure out by yourself, and a consultant would be a very wise thing to talk about, because there's going to be some costs involved in getting, especially to these higher injection levels beyond -14. This is some of the process that you go through in order to determine whether you have problems with adjacent channel protection. And what this basically will explain here, if I can move this thing out of the way so I can see, this is showing how the station that is intending to increase its coverage, how it potentially interfaces with the protected stations, the adjacent stations, either on the same frequency or an adjacent channel. This is adjacent channel protection. So this shows how the interference criteria that NPR put together that allows how you could increase your station based on the field strength at the protected 60 dBu 50/50 contour.
Right.
Okay. Then there's a whole policy of interference complaint remediation. Obviously, we're putting more power in the sidebands, up to 10 times more power in the sidebands, and those sidebands don't extend beyond the existing channel, but they do get right to the very limits of that channel bandwidth. And so there is the potential, because we're dealing with real-world receivers here, and we're dealing with things like blanketing interference and other things like that, there is the potential for complaints of interference. And the FCC has been very, I think, broad-minded about this and allowing the broadcasters to work this thing out by themselves with voluntary reductions, mutual resolution between parties. And then there's a whole policy put together for going beyond that if it's necessary. And hopefully that won't be necessary in most all cases. There's a notification procedure of what you must do when you decide you're going to increase your level. If all you're going to do is go to -14, you've got to notify the FCC within 10 days after commencing operation, and there's a digital notification form which is available to CDBS. For above -14, you have to file an informal request showing the calculation of proposed curves, 50-10 curves, on the protected 60 dBu contour. And there is an NPR Labs online calculator that has been up. I think it's temporarily down. I believe it may be coming back up. But in any case, it's probably a good idea to get a professional, a consultant involved in that process. Note that superpowered FMs must file an informal application for any proposed increase in digital power. Now let's talk specifically about your V Series transmitter and the M50 exciter. The M50 exciter does have adaptive pre-correction, which helps a lot. At the time the V Series and the M50 back in 2004 was developed, the only thing on the horizon was -20. So it's -14, -10, and those things were not even being considered at that point in time. And there are a lot of effects that happen when you take those digital sidebands and multiply them by 10 times power.
The big thing to remember here, excuse me, is that the mask is not changing.
Right.
So the effective spurious-free dynamic range of the transmitter has to be at least 6 dB greater. And the linearity of the transmitter has to be greater for this operating mode.
Yep.
At -14.
And in addition to this, the standards by which we measure these transmitters' spectral compliance have also changed in between 2004 and now. Is that right?
That's correct. The NRSC has adopted some specific parameters. Namely, you have to modulate the analog carrier 100% with the kilohertz tone.
1 kilohertz tone.
1 kilohertz tone. And in some cases, that increases the third-order intermodulation products, which are usually certainly one of the most kind of dominating factors for spectral compliance and usually determine your.
So most people would recognize this as being the shoulders on that.
That's right.
On that spectrum compliance chart on a spectrum analyzer.
Yeah.
So that makes things that not only have the requirements in terms of the spectral capability of the transmitter being able to increase dramatically, but in addition to that, the actual requirements for the performance has improved as well. Exactly. So that's a double whammy on your existing transmitter that was designed in 2004. Okay. You and your team are not surprised that minus 14 has come out. We weren't blindsided by this, but on the other hand, there's been a lot of effort going into new series products and new developments and things, and it needs to be said that the MV series today was designed with minus 14 and minus 10 in mind, and there was a lot of work that went into that. Now we're going back to the V series and saying, okay, how much can we get out of that existing design? And you guys have been doing a lot of work taking what we've learned in the MV and going back into the V series and saying, what can we implement?
Exactly. Yeah.
So these are pictures of a V10, which is down in the lab, and the engineers have been looking at the performance.
7.5 actually, but yeah.
7.5, all right. Been looking at the performance of that transmitter. And one thing that's really good is that since the V series was the very best Nautel had as a design standard before the NV was developed, an awful lot of the NV design came right out of the V series. The PA amplifiers are very similar.
Very similar, yes. Yeah.
So, and another thing to be thinking about here is that when you increase the injection level of the HD sidebands, the peak to average ratio goes up, and therefore the average power level of the amplifier goes down relative to its capability, and the efficiency of that amplifier goes down accordingly.
That's correct. So the peak to average ratio at minus 20 injection is around 1.4, depends on how much compression occurs in the transmitter, but around 1.4 dB, and at minus 14 it increases to around 2.5. So there's over a dB increase in the peak to average ratio, and yes, that results in a degradation in PA efficiency.
And so when you talk about reduced efficiency in the PA, then now we have two issues or two limitations of any amplifier design. Doesn't need to meet ours. It's a limitation of any amplifier going through this process. One is, as we've mentioned, linearity, which is spectral mass compliance, or the IM products of all of the independent signals that are occurring there. And the second one is thermal dissipation. If the efficiency goes down, that means the heat in the amplifier for the same given RF power output goes up. And since it's higher than where the amplifier was designed to build in the first place, now we have to analyze what is the new thermal dissipation of that amplifier.
Right.
So these are some shots of the test equipment set up that we've got measuring the temperature, measuring the spectral performance of an amplifier under test. And in fact, this is one of the semiconductor power amplifier transistor dies.
Correct.
You can see the two halves of the device there.
Gemini push-pull.
Right.
Topography.
On the PA, if you've got one of our PA V-Series amplifiers in front of you, you can probably imagine where that is. And here's the same thing with an infrared camera on it, in which we're actually measuring the temperature of the silicon die.
Right.
All right.
Because at the end of the day, that's the most crucial, temperature in the transmitter for long, reliable operation.
In my years of working on this, I found out that when that melts, you're off the air.
That's right.
Okay.
Yeah.
So,
well, just to give it a specific, so the maximum junction temperature allowed by the manufacturer is 200 degrees.
Right.
And that doesn't, if you were to reach that, you don't have, instant failure. It just means that you've reached a point that the MTBF is no longer acceptable, which would be, perhaps a few thousand hours of operation.
And a rule of thumb that I had heard in a past life was that every 10 degrees C warmer a device was, the life of that device was reduced by several orders of magnitude.
Yes, that's correct.
Yeah.
And so we have design standards where we keep the worst case operating temperature to be about 175 degrees.
So 25 degrees
25
headroom.
below, and so if that's worst case, so
That's a worst VisWire, worst line voltage,
right,
worst frequency.
Yeah, worst room temperature, which
right,
is
50 C.
50 C. So most people are 40, 30
yeah.
C. So that in itself gains.
What's 50 C in
I believe it's 112.
Way past where I'm comfortable.
Yeah.
Yeah.
That's
Okay.
Right.
All right. So let's continue going. And the idea here, and this is really why everybody's signed on here today, is to talk about what we're going to be able to do for you. And I wish I had what's that?
122.
What? Really hot.
Yeah,
really hot. I wish I had more of an answer, but here's the answer I have. Soon.
Yes.
And free, which is probably not something you're going to hear from other companies. We believe you're going to be able to upgrade your V Series to -14, assuming your transmitter has the headroom necessary.
Right. So there is the capability within the M50 exciter to adjust in the digital domain the relative amplitudes of the analog and the digital portion of the hybrid signal. And so we can do that. Obviously it has effect on the transmitter's efficiency, effect on the transmitter's power capability, and that's being characterized right now. There are several variables to this, frequency being one of them. Obviously, there's actually another variable which we haven't discussed even before this, is that the V transmitter has kind of a release 1 and a release 3 version with
sure.
different power supplies.
Continuous improvement.
Yeah, so all that's being characterized.
So there's a lot of testing going on. So we'll get into this strategy. There's also another strategy, which is a future strategy, and we're investigating a strategy which will allow people that can't get to -14 in scenario 1, or people that want to go beyond -14, like -12 or -10, or people who want to use HD power boost, which we'll explain a little bit, or people who the rules appear to make it easier for them to have unequal sideband level.
Right.
So that means like the upper sideband may be -12 and the lower sideband -14.
Exactly.
So that technology, unfortunately, doesn't exist within the M50 today. So we'll get to that in a second. For those that are fortunate that their transmitter has the headroom to go to -14, we will be letting everybody know within 30 days, as soon as the evaluation work that we're working on is finished. We'll contact all the V Series HD users that we're aware of with information on the headroom capability of their transmitter at their TPO and the instructions for the possible upgrade. And it's likely that there will be some modifications that they'll need to make on the PAs.
Minor, but yes.
Yep.
Yeah.
And that there will be this reconfiguration of the M50
There will be a procedure, and it's fairly straightforward.
Yep.
There's a serial port on the back of the M50, so you would need a laptop.
And we'll explain that here in a second.
We'll explain that, yeah.
Yeah, and then last step will be to recheck the spectral performance.
Right, so unlike the NV, I'm sure the V customers know this, that there's no built-in spectrum analyzer, so there needs to be emission verification.
Yeah, you need to make sure you're a good neighbor.
Yeah, exactly.
Okay. So the second step after you're contacted by Nautel will be to get the information about what potential you have for being upgraded to -14 and get those instructions from customer service. And you'll be provided with an instruction sheet and all that sort of information. And they will also give you instructions for what you need to do in terms of modifying the module. Then you'll go in with HyperTerminal into your M50, and there will be instructions indicated in there about how to tell the M50, instead of having the ratio of 20 dB, to go to the -14 number. And this will be some information you'll manually key in. And then the last step will be to double check your spectrum performance.
Correct.
and there'll be instructions on that as well, and how you can verify, how to set up your spectrum analyzer. Setting up your spectrum analyzer very, very important.
Yes, there's lots of variables there that can affect.
A lot of people have made some mistakes in that one.
Yeah.
Okay, so then after that, that's the easy one, and there's no cost from Nautel for that first blush. We're not, you know, I know that there's other manufacturers out there that are charging $30,000 and all this kind of thing. We're not doing that. This is not an opportunity to try to get more money from our customers. You've already bought your transmitter. However, there will be some people that won't fix. If their transmitter doesn't have enough headroom, or their exciter doesn't have enough headroom.
Correct.
Or they want to have levels beyond -14 dBc, or they want HD power boost or unequal HD sidebands. And unfortunately, you know, designed in 2004, the M50 is not compatible with those requirements. So we're looking at how an exciter upgrade, you know, the technology that we've developed for the MV series could be retrofitted into the V series, and to see whether we can add that functionality. Part of that process is why many of you may have been contacted by customer service or some of our sales representatives, determining how interested you would be in that upgrade capability. We're trying to determine how many people out there might want to have this functionality. Just to let you know, HD Power Boost provides more digital power. It can provide up to a dB or 1.3 dB improvement. And it will also provide, at the same time, because it's raising the average power out of the transmitter, can provide you a higher hybrid mode efficiency. I've got a slide specifically on that. It's using a software suite which has been implemented in the MV exciter. Typical return on investment in many cases, particularly higher powered stations, is 2 years just in electrical savings alone. And we're expecting to begin delivery sometime in Q2 of this year, which isn't all that far away. Here's
just to go back.
Yep.
You know,
go ahead.
Sometimes it's good to throw the dBs into the
real world,
yeah,
right?
So 1.3 dB is a 35% increase in power. That's
pretty impressive.
Nothing to sneeze at.
No.
That's you know. So that takes your 6 kilowatts up to close to 10 kilowatts.
Right, and just to make sure everybody understands too, this would mean replacing your M50 exciter with a new exciter.
That's right. That technology exists on the circuit card that is inside
the MV.
Yeah.
Or will be inside the MV.
Yes.
That requires tremendous amounts of computational power, and
lots of horsepower.
See, that wasn't available in 2004. So this is what you can expect in terms of injection level. This is based on a 40 kilowatt transmitter, but you can scale it down.
Yes.
You can see the kinds of savings with or without power boost, assuming a nominal cost of power.
Not only do you get the increase in power, you also get
an increase in efficiency. That's correct.
You're effectively reducing the peak to average ratio of the transmitter.
That's right.
You know, bringing it back closer to a almost analog operation.
Now I'm just looking here because I think we've reached the end of the prepared material, and I'm looking here on my screen to see if I can see if there's any questions, and I'm not seeing any of those at this point. If there's any questions, feel free to type them in here. But apart from that, we want to thank everybody for joining us today. These are the people in our sales department that you can contact. You can always contact me. I'm ckelly@nautel.com, or you can use the standard sales@nautel.com email address. There's also a webinar archive of all the webinars we've done in the last year or so, and there's a lot of information that's available there. This webinar will also be archived. If you joined us late, you certainly can jump in there and use and hear the entire webinar from the beginning. Again, I'm not seeing, unless I'm missing something, any questions on the sheet here. So with that, I guess we'll sign off and thank everyone. And please do send us emails if there's questions that you'd like answered. For those of you, I apologize it's not faster, but please do give us 30 days to get back with you with the information about the upgrading of your V Series transmitter and the capabilities you'll have. Thanks very much for joining us, and good day from Halifax, Nova Scotia.